Everyone is talking about one number: $25,000. That price is everywhere, on headlines, on thumbnails, across social media debates. But focusing on the price is a mistake, because the most important change in electric vehicles is not visible on the surface. It is not written on the sticker. It is not even obvious when you open the door. The real revolution is happening much deeper, inside the battery itself, at a level most people never think about. Right now, Tesla is preparing to move beyond lithium-ion technology. The same battery chemistry that powered the electric vehicle revolution for more than a decade is approaching its limits. And the surprising part is this: the replacement may not depend on rare or exotic materials. Instead, it could be based on aluminum, or something even more ordinary: salt. Imagine an electric car that charges faster than your morning coffee cools down. A vehicle designed to last for millions of miles. It sounds unrealistic, almost impossible, but laboratory testing suggests this future may be much closer than anyone expected. Inside Tesla's research facilities, engineers are working on two radically different battery chemistries. One focuses on extreme charging speed. The other focuses on extraordinary durability. Whichever technology succeeds will shape the future of electric transportation. This is the industrial battle happening behind Tesla's next-generation vehicle. For more than a decade, lithium-ion batteries have powered the electric vehicle industry. They enabled long driving ranges, acceptable charging times, and large-scale production. But lithium batteries come with serious limitations. They are expensive. They slowly degrade over time. They rely on complex global supply chains, and under extreme conditions, they can be unstable. Even the most advanced lithium battery packs gradually lose capacity. After hundreds of thousands of miles, performance begins to decline. At the same time, lithium prices have surged. Mining and refining are concentrated in only a few regions of the world. This creates supply risks, political pressure, and rising costs. As electric vehicle adoption accelerates worldwide, these weaknesses become impossible to ignore. Tesla understands this reality better than anyone, and instead of pushing lithium technology to its breaking point, the company appears to be preparing for something entirely new. The first alternative gaining serious attention is aluminum-ion battery technology. At first glance, aluminum seems like an unlikely candidate. Its energy density is lower than lithium, which traditionally means a shorter driving range. But range is only one part of the equation. Where aluminum truly stands out is speed. Aluminum-ion batteries can accept charge at extremely high rates. In laboratory conditions, full recharges have been demonstrated in minutes rather than hours. A 10-minute recharge does not feel like charging. It feels like a brief stop. This completely changes how drivers interact with electric vehicles. Instead of planning long charging sessions, recharging becomes almost incidental. Durability is another major advantage. While lithium batteries slowly degrade, aluminum-based cells show remarkable resistance to wear. Some designs are rated for thousands of full charge cycles. That translates into a potential lifespan exceeding 2 million miles. In practical terms, a vehicle using this technology could outlast multiple owners. And then there is cost. Aluminum is one of the most abundant metals on Earth. It is widely available, inexpensive, and already deeply integrated into global manufacturing. Compared to lithium, aluminum costs a fraction of the price. For Tesla, this represents a massive strategic advantage. Lower material costs mean cheaper batteries. Cheaper batteries mean more affordable vehicles. This is how Tesla can reach mass market pricing without sacrificing profit. Aluminum-ion batteries also enable a complete manufacturing redesign. Traditional battery packs are complex systems. They require thick casings, cooling loops, separators, and multiple safety layers. Aluminum-based designs are inherently more stable. This allows engineers to remove unnecessary protective components. Less structure, less weight, less complexity. In some designs, the battery itself becomes part of the vehicle's structure. Instead of inserting cells into a heavy box, the battery is integrated directly into the floor of the car. This approach reduces weight while increasing rigidity. By replacing heavy metals like nickel and cobalt with lightweight aluminum, hundreds of pounds can be eliminated. A lighter vehicle accelerates faster, handles better, and consumes less energy. Suddenly, a slightly shorter range becomes irrelevant, because when charging takes minutes instead of hours, range anxiety disappears. But aluminum is not the only option Tesla is exploring. The second alternative may be even more disruptive. Sodium-ion batteries rely on one of the most abundant materials on Earth: sodium, salt. Sodium is thousands of times more plentiful than lithium. It can be sourced almost anywhere, and it is dramatically cheaper. While lithium refining is concentrated overseas, sodium processing can be localized. This eliminates supply bottlenecks and geopolitical risk. The cost reductions are enormous. Sodium-ion batteries are projected to cut battery costs nearly in half. And unlike lithium, sodium chemistry performs exceptionally well in extreme temperatures. Cold weather has little effect. High heat becomes far less dangerous. Safety improves, longevity increases. Some experimental sodium cells are rated for tens of thousands of charge cycles. That equates to a theoretical lifespan of 3 million miles. At that point, battery replacement, one of the biggest fears of electric vehicle ownership, disappears. The vehicle does not just last longer, it retains value for decades. Tesla's next-generation compact vehicle depends entirely on battery innovation. To reach aggressive pricing targets, battery costs must fall dramatically. Aluminum-ion batteries offer speed and structural efficiency. Sodium-ion batteries offer affordability and unmatched durability. Each approach involves trade-offs. One prioritizes charging time, the other prioritizes lifespan. But both share the same outcome. They make electric vehicles accessible to the mass market. This is not about competing with luxury brands. It is about replacing internal combustion engines entirely. The future of electric vehicles will not be decided by design alone. It will be decided by chemistry, by materials hidden beneath the surface. Whether Tesla chooses aluminum, sodium, or a combination of both, one thing is clear: lithium will not dominate forever. If you had the choice, would you prefer ultra-fast charging or a battery that lasts a lifetime? Let us know in the comments. And for deep dives into the technology shaping tomorrow, subscribe to Prodexia AI. Because the future is not coming. It is already being built.